Ready, go. Okay, so this is a new Öhlins shock for Lambretta. I think they've done quite a good job of it. The shock's got three types of adjustment. The first is a screw thread for preloading the spring. What preloading the spring does is set the point at which the spring starts to compress, how much load it requires before it starts moving, and this you will need to adjust depending on whether you're 1 up or 2 up. And you can use this to set your sag, which is how much the shock compresses when you're sat on the bike as if you were ready to ride. On this they've done quite a clever job, which is they've added a nylon screw in there, which obviously won't mark the thread like a metal screw would, and then they provide this little L-shaped tool, just a round tool that you put in and you can use to spin the adjuster. One of the things that you'll notice about this spring is that it's progressively wound. So the longer a spring is, the softer it is. What happens on a spring like this is that these tightly wound coils at the top, they'll compress together, effectively shortening the length of the spring, so that only these coils are the ones that are bending, which means that it will effectively get stiffer as it compresses. When you hit a bump and compress a spring, all you're doing is storing energy. Basically, you're putting energy into movement of that spring, and because it's a spring, all it does is return that energy back down. What dampers do is they slow that, they dissipate some of that energy, and they release it as heat. Inside the shock body, there's on the end of the rod is a piston, and there's oil on both sides of the piston. And as the piston tries to move through the oil, orifices inside, which can be controlled using the damper adjustments, and also stacks of shims that have been predetermined, control the rate at which the shock can move in one direction or another. When the shock is trying to extend after it's been compressed, that's called rebound damping. So it's slowing the extension of the shock back to its standard length. When you hit a bump and the shock is being compressed, you can also slow that process down. And both of these are designed to reduce oscillations that you'll get normally from a spring. This adjuster here is the rebound adjuster. This one sets the rate at which the shock can extend after you've hit a bump. So to demonstrate the difference in the suspension responses, this is the rebound. I want to set it all the way this way, which is anti-clockwise. That's off the end of the scale. And you can see that there's nothing there. It's oscillating almost without any opposition. So if I put it back all the way down to the bottom, which as I'm looking down on it, clockwise is that way. And now if I demonstrate with it the maximum rebound damping, watch how slowly this responds. It's so graphic how slow that extends. So Öhlins very helpfully provide setup data for this shock. They suggest 10mm of thread as preload on this. They suggest 14 clicks on the rebound adjuster. Now when they count clicks, that will be counted anti-clockwise from wound all the way down. If you try counting from the other end, you'll be counting in the wrong direction, but also when you've fully rewound it, it tends to stop clicking, and that's common on lots of shocks. So you'd wind it all the way down, which would be its hardest setting, and then you count back 14 clicks. So if I wind it all the way down, and that's as far as it's going to go. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. That's roughly in the middle of the range, is over 30 clicks in there. The idea being that it should extend but not oscillate. This adjuster down here is the compression adjuster. This one controls the speed that the shock is allowed to move when it hits a bump. For the compression damper, they suggest 18 clicks, and it does 20. So you'd wind it all the way in, and then looking at it, you'd wind it anti-clockwise, 18 clicks out of about 20 or 21 clicks before it stops clicking. So that's really on the lower limit of the compression damping, and I would agree that you don't need a great deal. So most shocks from other manufacturers come with similar setup in that they've got a preload adjuster. This one from OCO's also got a progressively wound spring, but more common is that you only get one damping adjuster. Now if you have only one damping adjuster and you don't have any instructions, then my preference would be to start at the softer end of things. Winding, as you look at it, winding in clockwise would make the damping harder. So you count how many clicks it is until the end, and then wind back 2 or 3 just to get started. If that's not enough and the engine still oscillates, you add a bit more. But this is adding on compression at the same time as rebound. So basically it will just get stiffer and stiffer and stiffer. So first of all, let's have a chat about sag and what sag is. Sag, I can demonstrate here, is even though the bike's on its centre stand, the shock has still got the weight at the back of the bike on it. So there is a little bit of sag. It's partially compressed the spring. I can demonstrate this by pushing on lifting up the rear, and you can see that the shock extends slightly. So there's already sag on there. The importance of having some sag is that when you go over a bump and the bike goes light, if the shock was already fully extended, what would happen is the bike would crest and the tyre would leave the road. You don't want that to happen. You want to maintain grip as much as possible. So when you've got sag, there's also a possibility of the engine to drop down further, the wheel to follow the road if the bike goes light, and then it helps with the tyre grip. That's also important for cornering as well. So in the Öhlins manual, they suggest, and this is a generic manual for all their shocks for motorbikes, they suggest having a free sag which is 5 to 15 millimeters. Free sag would be when the bike's off its stand. At the moment it's on the centre stand, so it's not even carrying the whole weight of the bike. Then they suggest setting the ride height, which is where the shock sits once you've got a person sat on it and it's off the stand. of 25 to 35 millimeters. So that's 25 to 35 millimeters out of a shock that's only got 80 millimeters of movement, which seems, you know, it's a third of travel. We can measure the free sag by measuring from centre to centre. We know the shock is supposed to be around 304, 305 mil from centre to centre. I was trying to figure out a way to measure and test the ride height, and I came up with these, which I've 3D printed, and they're going to be available for free to download the files on Thingiverse. If you've got access to somebody, you can print these for you. So all I've done is I've put a load of hexes in there so that you can put them directly onto the nuts. One end I have got a bit of bent metal in there that's held in with a cable tie, so this is fixed. And then on this part here, there's a cable tie that will slide that you can use for measuring travel and also sag. You put the two on like that. And just simply press them onto the nut. And if you set that to the high point, as soon as you sit on it, it will push down, and then you get an idea of what the sag level is. Now if you want to measure as well, I also printed these with little slots in, so it's easy to stick a tape measure in and measure directly from one slot to the next. Couldn't be any easier than that. So at the moment I'm measuring with a set of verniers this time. I think that there's about 11 and a half mil of thread at the bottom there. So that's my preload. It's a bit up from what they suggest, which was 10. And there's still some static sag, so I can measure, if I lift the back of the bike up, there's about 2.5 mil of static sag just from the weight of the bike, even on the stand. So I'm going to take it off the stand now, and we'll see when I sit on it what the actual sag level is. So that's me sat normally. Now if I get off, 17.5 mil. So that's harder than they would set it, but I'm a bit heavier than normal. So I'm going to give that a go. If I get asked for my glamorous passenger to come and sit on the back, we can check what changes, how that changes.
No comments about cake eating.
Right, okay. Right, okay. Right, so you can get off now. Glamorous assistant. We've got 32 millimeters of sag, which is out of the 56 that we used before. Means that most of the suspension travel has been used up. My setting where I had the shock set to was about 11.5 millimeters of thread. So they say their maximum range is up to 20. So if I add another 10 millimeters of the here, I should lose 10 millimeters off that, in theory. First of all, undo the lock nut. And then I've got to do all my winding. I've wound the preload adjuster up, so there's 20 millimeters of thread, which is kind of the limit, the upper limit that the Öhlins suggest. Adjust the thing so that we can check again. So this is me one up. It still sags a little bit. Glamorous assistant, I'll sit back on. Okay. Right, so do you want to get off? Now our sag has dropped to 24 millimeters from something like 32. So really, we want to wind it on a bit further if we're going to be riding two up. But you get the idea. What you may need to do is add a little bit of rebound damping, and maybe add a little bit of compression damping. You add rebound damping again to slow oscillations down and get the shock to set level. You can add compression damping if it feels like the shock's going to bottom out before too early. You can slow down the rate that the shock absorbs bumps. Here we go. Okay, go. That's good. That one was good, yeah. So my preference for setting up scooter shocks where you don't have any instructions would be to add the minimum amount of sag so that you still get some movement when you sit on the bike. You don't want it set so hard that when you sit on it nothing moves. So you set on a minimum amount of preload. Then you also set on a minimal amount of damping, rebound damping, or in this case rebound and compression working together. And start low and then work your way up to calm any oscillations of the bike, any weaving that you'll get on the road, because the ride will be more comfortable with less damping, but equally you need to keep the bike under control. So it's a matter of finding a happy medium. When it comes to something that's got separate rebound and compression, then it's a case of, if you have to add more preload because you're riding with a passenger, you might add 1 or 2 clicks of rebound damping. Then your compression damping, you'll be adding some if the bike feels wallowy or if it feels like it's bottoming out. You can slow the progress of the suspension compressing, but if the bike feels harsh or you feel a lot of jolts through the suspension, you can wind off the compression damping a little bit. So inside there, I'm Bob Fleming today. Arseholes. Right.